Hi guys, this is from Module 9, Properties of Quadrilaterals. And basically, let's get started with listing off the properties that are true for squares. So if you guys remember, we had um, a little diagram, okay, of quadrilaterals. It was a Venn diagram, quadrilaterals, and then parallelograms, and then rectangles okay, so again, here's parallelograms, okay, and then rectangles were here, and rhombuses were over here, and squares were being shared between rectangles and rhombus. Okay, so again, rectangles, we had rhombus, okay, and that was inside the whole parallelograms. So that's the idea here is what are the properties for squares? So squares, okay, let me draw it. And I think that was the uh, scary thing that I mentioned earlier was that squares are rectangles and they're also rhombuses. All right. So squares are simply this: we have four congruent sides, just like a rhombus, except the angles have to be 90 degrees. Okay. Their diagonals are perpendicular. Okay. So that's another thing, just like a rhombus. All right. So again, four congruent sides. We have all right angles. We also have perpendicular um, perpendicular diagonals. Sorry. Um, Let me try to remember. Oh yeah, their diagonals are congruent to each other, but then again, that's very similar to a rectangle as well. So that's about it. We have four congruent sides, all right angles, perpendicular diagonals, therefore they have to intersect at 90 degrees as well. Diagonals are all congruent to each other. Okay, so that's something to note. But yeah, that's about it for triangle or for squares. Okay, so remember a square is technically a rectangle and technically a rhombus at the same time. It's being shared by those two. Okay, which makes sense with the diagram that I drew. All right, so list all the properties that are true for parallelograms. Oh boy. Okay, so first off, oh yeah, don't forget about let's see, opposite angles. So if I was to draw a simple parallelogram, again, that's the same with squares too. Opposite angles are congruent. So I kind of forgot about that. All right. So for example, let me draw over here. Here's a parallelogram. This angle and this angle have to be a congruent. So if I was to label them, um, angle B would have to be congruent to angle D. Okay, so if angle B was 30 degrees, angle D would also have to be 30 degrees. So that's one of them. So again, opposite angles are congruent, are always, okay, congruent. Um, Opposite sides are always congruent. Um, Opposite sides are also parallel. Okay, so same thing with that square from earlier. That side is parallel to this side, and this side is parallel to this side. So that's also something I kind of left out. Um, So again, opposite sides are parallel because technically a square is also a parallelogram. All right. So don't forget that little tidbit. All right. So again, opposite angles are always congruent. The sides are, or at least the opposite sides, okay, are congruent. All right. So this side would have to be congruent to this side. This side has to be congruent to this side. Now remember, squares and rhombuses are the only parallelograms where all their sides are congruent to one another. So that's something special about them. Remember, a rhombus is really just a square that somebody sat on. All right, properties that are true for parallelograms. Again, diagonals are congruent, or diagonals always bisect each other. So make sure you remember that as well. Okay. All right, list of properties of rectangles and rhombuses that are the same and that are different. Okay, so let's go ahead and draw the rectangle. We got 90 degrees here every time. Um, Rhombuses, on the other hand, can be a little bit more flexible in their angles. Now, same, they're opposite angles, are always congruent. All right, so that's something to notice. Their opposite angles are always congruent. Um, Opposite sides are always congruent. So that's something else that you should probably note. Um, Diagonals bisect each other. Um, don't forget opposite sides are parallel as well to one another. Now, different. A rhombus um, uh, doesn't need right angles. Okay, it can, but by that time it's really just a square. Doesn't need right angles. Okay, it's more flexible. A rectangle has to have 90. Okay, so a rectangle needs 90-degree angles. Um, and remember, sometimes for a rectangle, all four sides can be congruent, and that's where we would call it a square, which technically is a rectangle. Um, Now, another thing to note is if you had these diagonals here, they're diagonals. A rhombus has diagonals. Sorry, that's a terrible S. Has diagonals that are also angle bisectors. So that's something kind of special. So again, this angle would be congruent to this angle. All right. So remember, that's the interesting thing about rhombuses and their diagonals. All right. Different. Um, yeah, if there's any more that I missed, guys, just please let me know. Okay. So also debate this with your friends. All right. So part A, number 4, if ABCD is a parallelogram, what would it have to be true? Um, that's a really good question. Well, BC, his opposite angle has to be congruent to him, which is AD. Okay. Now, if we were to set that up to find um, the length of a segment, particularly BC, the setup would be what? You got 7 uh, x. Let me do this in order. I apologize. Let me do this. So the setup would be this. BC, which was 5x plus 19, should equal AD, which is 7x. Solve for x, plug it back in, and you should get your side length. Okay, so that's the setup for the idea for, again, congruency for a parallelogram. Now, to find the measures for measure B, for the measure of angle B, we know again the opposite angles have to be congruent. So you would just set them equal to each other and solve. Again, the measure for angle B is also congruent to the measure of angle D, and then you just set it up as such. So angle B was 6y plus 5, set it equal to angle D, solve for y, then whatever you get for y, you plug it back in for measure B, and there's your answer. So whatever you get, let me know. I'm not going to do the algebra for you. Just remember the setup and practice your algebra. All right, number 5, determine if each quadrilateral must be a parallelogram. Okay, so if this side is congruent to this side, we get 207. Now we know that total-wise, we should get 360 degrees because it's a quadrilateral. So if you remember that formula, n minus 2 times 180, okay, we have 4 sides, so 4 minus 2, 2 times 180 is 360. And you can always use that to kind of verify whether or not this is a parallelogram. So go ahead, you got your 214 plus that 73, I get 287. And if I subtract that from 360, I get 73 as my remainder, which is my missing side here. And since my opposite angles are congruent, ding, ding, ding. Okay, that's definitely a parallelogram since it does satisfy that criterion of where opposite angles are congruent, and that would help out a lot. So let's check part B. Their opposite sides are, or at least these opposite sides are congruent. They mark them for us. The This diagonal is bisected, but they didn't really give us enough about the other diagonal, and they didn't really give us enough for the opposite sides. So it's like all we have are two separate parts that don't really help. You know what I mean? It's like this problem if they were just to give us let's say 73 degrees and then 4 feet for this side. Not enough for us to go off of. You know what I mean? So we're not 100% because they didn't really give us enough to really go off the criterion. I mean, they gave us this diagonal, but what about the other diagonal? They gave us these opposite sides, but what about the other opposite sides? You know, they didn't really specify. So that's always something to kind of talk about. It's like, oh yeah, this is 4, length of 4, and this piece is a length of 4, and then it's like, okay, what about the other sides? Like, that's not really a lot to go off of there, buddy. All right. So number 6, this is actually from your homework. Just looking at it, um, this is really just Pythagorean theorem. So again, if you were to find what AC plus BD is, this is a rectangle. Okay, and rectangles have 90-degree right angles for their interior. Now that's basically just right angles or right triangles, right? So if AB is 21 and then AD was 28, well, we have to find what BD is. And BD is really just the hypotenuse of this right triangle. Okay, so all you really have to do is, well, it's going to be AB squared, okay, plus AD squared equals BD squared. Okay, solve for BD. Don't forget to do the whole square root bit. And then whatever you get there, remember AC has to be congruent to BC. So whatever you get for BD, you're really just adding another BD together. Now, what's kind of funny about part B, if you realize that no matter what numbers they give you here, they're asking you to do BD minus AC. And we already just said BD is congruent to AC. So what happens when two numbers that are the same are subtracting each other? The answer is going to be 0. So that's a nice thing to know about the property of diagonals for rectangles, especially, um, or any parallelogram, um, to get an answer real quick. All right, you didn't even have to use Pythagorean theorem. Not even waste your time. It's awesome. All right, number 7. Determine which quadrilaterals match the figure: parallelogram, rhombus, rectangle, or square. List all that applies. So I think they're talking about A and B. Now they do give us some things. They tell us that XY is congruent to ZW. Okay, notice how I'm marking them. And then XY is parallel to ZW. Okay, that's good to know. All right, so then they tell us Y or WY is congruent to ZW. So their diagonals are congruent to one another. And that YW, ooh, is perpendicular to XZ. So that means this is cut at a 90 degree. Now, what's interesting is their diagonals are congruent to each other. So this is definitely either going to be a square or a rhombus. It's a square or a rhombus because, again, of this reason. This kind of refines our search, okay, um, quite a bit because that means our diagonals are cut at 90 degrees. The only two shapes that do that is going to be the rhombus or square. Now, they do tell us that XY is congruent to YZ, but they do not tell us for sure that um, XW and YZ are congruent. Okay, they don't say anything over here. But what's really crazy is if we think about triangle congruency. Okay, XZ is congruent to itself, but it's also congruent to S or YW. Okay, so we have this side being the same as this side. Then we have this side being the same as this side. And we know 90-degree angles, so this angle should be the same as this angle. And you could probably do a whole proof on triangle congruency to state that YZ is congruent to the other two given sides. And you could probably make a stretch about that, and that way you can get like a whole square situation going on. But it's definitely a square or a rhombus. And just be aware of your triangle congruencies. See if you can prove the triangles are congruent to each other. And then don't forget CPCTC. But yeah, so be aware of those things. Now, let's look at B. XY is congruent to ZW, so let's go ahead and mark it. Okay, let's tag it. And then XY is congruent to ZY. Okay, already I'm thinking rectangle, okay, or just a parallelogram in general. Now, they do tell us that, well, let's see, WY is congruent to ZY, so their diagonals are congruent. Okay, that means they bisect each other. So I'm thinking for sure a parallelogram and or a rectangle. So talk to your group and see which one would you rather focus on. Are we 100% sure it's a rectangle? Did they say anything about 90-degree angles? They didn't really say that, did they? So have that conversation and determine which one you think it really is. Same thing with part A. Get that discussion going with your group. All right, number 8. Find the measure. Okay, I'll tell you what, I'm only going to set it up for you, but remember the main idea. ABCD is a parallelogram, and they're asking us to find angle B. Now, angle B is right here. We know that the opposites have to be congruent. So to solve for angle B, or the measure for angle B, we have to set it equal to the measure of angle D. So measure B, again, was 9x minus 5 degrees, which should equal the same expression, 10x minus 19. All right, not the same expression, but the same congruent angle. All right, and solve for x, plug it back in, find the measure for angle B. Okay. AD. Okay, well, we know AD has to be congruent to the opposite side, which is BC. So we just set it up as thus. So AD, again, is congruent to BC. And the setup should look like this. You have AD, which is 3y, minus 1, which is equal to the expression for BC, which is y plus 15. So be aware of how to use your subtraction properties, addition properties, division properties, and or just your properties of equality. Solve for y, plug it back in, and get your measure for angle or for side AD. All right, same situation here. In fact, I'll go ahead and make this your homework. Okay. Same thing with number 8, actually. Go ahead, solve for x and y, plug it back in, give me some measurements. Same thing with number 9. Okay, so that's for you. Now, other theorems to review, make sure you review angle, side angle, side, angle side, and uh, hypotenuse leg triangle congruency theorems. Be aware of those in proofs. So, for example, if I was to show that these two triangles were congruent to one another, and we had this side being congruent to this side being congruent to this side, and this side being congruent to this side, that is side triangle congruency. So be aware of how to read that. If you want to look at mod 5.6 performance task, it should be in your notebook still. That's the one where we did all the matching. So that's a good thing to review. Okay. So review, look at, practice, see if there's any practice for you, and just kind of study that, brush up on it. Reflexive property. So remember, in certain situations, if you had two triangles that were sharing the same line, let's say AB, and AB is congruent to itself, okay? Because both triangle ABD and ABC are sharing AB for one of its sides. So that's a reflexive property. Now, moving on to CPCTC, remember, if I prove that triangle ABD, okay, this triangle right here is congruent to this triangle right here, that means this little part has to be congruent to that guy's little part. Okay, and that's what the P stands for in CPCTC. It's parts. So, again, corresponding parts of congruent triangles are congruent. So remember that. Look over it. Review it. Alternate interior angles. Okay, look like this. So these should be congruent to one another. And the converses in regards to parallel lines. So again, if these two angles are congruent, therefore these are parallel. Okay, so that's the converse. Okay, guys, so that's the end of the study guide. If you have any questions, let me know. And again, just look over all your notes and you should be just fine. All right, thank you.